I'm going to leave the collection side of the Java Collections framework for now and look at the map interface and the Java classes that implement it. The map interface is part of the collections framework, even though it doesn't derive from or implement the collection interface. From this diagram on the slide, you can obviously see the map is out here on its own. A map in the collections framework is another data structure. Although it's still a grouping of elements, it's different because elements are stored with keyed references. This means a map requires two type arguments, as you can see on this slide, where I'm showing the root interface collection compared to the map interface. The map has K for its key type and V for the value type. As with any generic classes, the only restriction on these types is that they must be reference types and not primitives. The map interface replaces the now obsolete dictionary abstract class, and like the class that it replaces, it maps one key to one value. A language dictionary is a classic example of a map, with the keys being the words in the dictionaries and the values would be the definitions of the words. Unfortunately, this analogy falls down a bit with the English language, and the reason for that is many English words have the same meanings. The word put, for example, has 4 definitions, 2 as a verb and 2 as a noun. A Java map can't contain duplicate keys, so I couldn't have 4 keys all named put in my map. Each key can only map to a single value, so I couldn't reference 4 different string descriptions for the key put without aggregating the descriptions into a collection of some sort. In the next few videos, I'll be looking at 3 of the Java classes that implement the map interface, the hash map, the linked hash map, and the tree map. The hash map is unordered, the linked hash map is ordered by insertion order, and the tree map is a sorted map. I want to continue with the contact merge example I used in the set discussion, so I've got my sets and maps project opened. Remember, this has a contact class that represents either a phone or email contact or both. A map is a much easier data structure to work with if you're doing updates to a keyed item. I'll create a new class called mapMain with a main method. First, I want to get a list of phone and email contacts, creating a combined list. I've done this before. I'm going to have 2 lists, one for phones, getting that from getData on the contact data class, first passing phone for the type. For the emails list, I'll do the same thing, but pass the type email. I'll create a full list, assigning that a new instance of an array list and passing that phones. Next, I'll add the emails list, and I'll print those elements out with a separator line. I get a list with duplicate records, one for each phone number and email record, each individual record in other words. Records in a list are by default in insertion order and include all duplicates. Next, I want to create my first map, and I'm going to start with a hash map. I have to specify 2 type arguments when I do this. The first type is the type of the key, and the second is the type of the value or collection element. I'll use map as my reference type, and my key is going to be the contact name, so string, and the value is going to be a contact record. I'll assign a new instance of the hash map to that, with nothing passed to the constructor. Unlike the classes with collection at their root, map implementations don't have an add all method, and I can't simply pass collection types to the constructor, only other map types. To add my contacts, I'm going to loop through the full list and use the put method on my hash map. The put method takes a key and a value and inserts what's called an entry into the map. I'll pass the name using getNameOnContact as the key and my current contact as the value. Now I want to print out my elements in the map. There are multiple ways to do this, but I'll start with the for each method on the map itself on contacts and pass it a lambda expression. This lambda expression requires 2 arguments, one for the key and one for the value, and I'll call those k and v for simplicity and to save a little space. My expression will just print the key and the value here. Running this class's main method now to check what this outputs. You can see the keys are the contact names and the values are the contact records. These elements aren't in any particular order. Also notice that there's no duplicates of either key or value. Keys must be unique, but also I want you to see that Mickey's contact has an email and not a phone number. Why is that when the full list, which is an array list, listed Mickey records with the phone numbers first? Wouldn't this mean that the first Mickey record with phone number 999-888-7777 would have been added first and other records ignored. Remember when we called add on a set, it would return true or false, false if the element wasn't added because it was already in the set, and true if it was added successfully. The map's put method is different than the set's add method because the put method always puts the element in the map. If the key is not in the map, the key and value are added. If the key is in the map, the value is replaced and the previous value is returned from the put method. For a map, this means the last element in your list is the one that ends up in your map, which is what happened here. There are other methods for adding elements to the map, and I'll discuss each of these in turn. But before that, something about a map that makes it so nice to use is that I can simply use the key value to look up my contact. I will do that next, so first I'll print a separation line, then I'll print the result of the get method, and for a map I pass the key to that, the string Charlie Brown. Running that now. You can see the get method successfully retrieved my Charlie Brown contact record. If Charlie Brown is not a key in the map, the get method would return a null. JDK8 introduced a method called getOrDefault, which will replace that null value with a default value. Let's look at that for a moment. First I'll use the get method and pass it Chuck Brown, passing that directly to a println method. And you can see when I run that, it just prints a null. There may be some cases where you're chaining methods, for example, where you really don't want a null back because it will cause a null reference exception to occur. I'll create a default contact for Chuck Brown by just passing his name to the contact constructor. Here, I'll use the getOrDefault method with the Chuck Brown key and also pass it the default contact. If I run that code now, you can see that gives me a contact record back for Chuck Brown with no other data. It's important to remember though that Chuck Brown never gets added to the map. That contact is just there, the default contact as a convenience. The put method will also return a null if the element isn't found in the map or the element if it is. I'll add another separator line and now I'll clear the contacts map of elements using contacts.clear. I'll again loop through the contacts. This time, I'll assign the store the return value of the put method into a local variable. If that's not null, I'll print the value that came back as well as the current value, which is the value that always gets put in the map. In this code, I can recognize a duplicate if something other than null is returned from the put method. Running this code should print duplicate records by name as well as the record that I'm iterating over, the current contact. And it did just that, as you can see. I can use this bit of information to my advantage, especially since my objective is to merge my contacts. First, I'll comment out those two print statements in this loop. I'll call my merge contact data method when this situation occurs, and then put the new contact that comes back from that in the map. I'll make another call to the put method on contacts using the same key, and then pass a call to merge contact data as the expression for the second argument. If I pass that the duplicate entry, I'll get a new contact with the current and duplicate data merged. I want to copy that for each statement that prints the whole map out on line 25 and paste it after this loop. Can you guess what the results of this will be now? Let me run it so we can check. As you can see, I have a distinct listing of my contacts with merged emails and phone numbers. You can see Mickey Mouse has 2 distinct emails and 2 distinct phone numbers. Merging my contacts was quick work using a hash map. Now let's just say I didn't really want to merge these elements, but I also don't want each additional matching record to replace the initial entry either. In other words, I don't want to replace the value every time I do a put. First, I'll add 2 statements, a separation line and a call to clear the map again. I'm going to copy that first for loop, the code between lines 22 through 25, and paste that at the end of this main method. And instead of put, I'll use another method called put_if_absent, which is a default method on the map interface. I'll run this now, and you can see it worked. I want to talk about the differences between put and put_if_absent. Looking at the results of my map, you can see that Mickey's record reflects the first record I had in my full list, meaning this record has the phone number 999-888-7777. The put_if_absent method won't put an updated value in the map, it just ignores the element if it already finds something in the map for the key. Again, this method returns an element if one is already in the map for the key, but the method doesn't replace it with the current element. It returns null if this is the first time an entry is being added to the map for that key. If I wanted to merge contacts in this case, I could do something similar, so I'll copy the statements from lines 47 to 53 and paste them here on line 55. In this loop, I want to assign what comes back from putIfAbsent to a local variable, and I'll call that duplicate. I'll add an if statement checking if duplicate isn't null, and if it isn't, I'll make a call to put. I'll put my merged contact, again merging the current contact with the duplicate variable. And running that code, I again get my contacts nicely merged. There's still another method introduced in JDK8 that I can use rather than doing this kind of check with put or putIfAbsent. That's the merge method. It also takes a key and a value, but the third parameter is a bifunction interface, meaning it's a target for a lambda expression that takes two parameters and returns a result. I'll print yet another separator line and clear my contacts map. I'll loop through my full list, but this time I'm going to do it with the forEach method. That takes a lambda expression, and in there I'm just going to call merge on the contacts map, passing the current contact's name, then the current contact. I need to follow that with another lambda expression. I'll leave a placeholder here for a moment. Finally, I'll print the elements in the contacts map after this call. This next lambda is a function interface, and in this case, my two types and result are all going to be the same type, contact. I need to set up two parameters in my lambda, and I'm going to call them previous and current, and now I'll set up a multi-line lambda, so an opening curly brace. I want to print out the previous and the current contacts. I'll call merge contact data to merge the data on my two contacts. I'll print the merged contact and return it from this nested lambda expression. This looks like a lot, but bear with me for a moment here. There's a reason I'm using the forEach method and not the enhanced for loop, which might have been a little bit easier to see. I'll run the code. You can now see the progression of the merge happening with both the previous current and merged contact printed out. If I just look at Mickey Mouse's progression, I can see that the map started out with the 999 phone contact, then it merged that with the 124 number, and it continues to merge any elements where the key already exists in the map. Then I've got the full map printed after that, and all my elements are again nicely merged. Okay, so let's clean this code up a bit and get rid of the print statements in my lambda expression. I want to collapse this multi-line lambda into a single line lambda expression. I'll remove the opening bracket and the new line. I want to remove contact merged equals and the ending semicolon. After that, I'll remove the return statement altogether, as well as the closing bracket. And running this, the result is the same. However, IntelliJ is telling me I can even make this more succinct. You can see that previous .merge contact data is highlighted. I'll hover over that, and you can see that it says I can replace this entire lambda expression with a method reference, so I'll do that. This gives us the exact same results. That's a neat little bit of code that lets me merge a bunch of contacts from an array list into a hash map with a single statement. Who doesn't love one statement of code that does all the work for us? I'm going to end this video here. In the next video, I'll cover additional default methods on map, as well as others implemented on the HashMap class itself. See you in the next video.